Hello and welcome to today's lesson looking at Group 1 of the periodic table. In previous lessons we've spoken about elements, compounds and mixtures, and we've also spoken about the structure of the periodic table. So in your books, if you could write the title, the periodic table, Group 1, as you would do for any other lesson. Our learning objectives today are as follows. By the end of the lesson, you should be able to recall where Group 1 is on the periodic table. You should be able to describe some of the properties of the elements in Group 1, and you should be able to compare the properties of Group 1 metals with those of other metals. So just to refresh your memory, we did speak about this a few lessons ago, but groups of the periodic table, so groups are the vertical columns, of the periodic table that run from the top to the bottom. So the groups run from the top of the periodic table to the bottom. Now Group 1, which are the metals we're going to be talking about today, are found in this first column. They run from the top to the bottom, so they are a group, and we call these Group 1. They include the metals lithium, sodium, potassium, rubidium, cesium, and francium, which we will be talking about today. So we can say, and I'm going to put in regs, it's important, Group 1 elements are metals as they are on the left-hand side of the periodic table. Okay, so the Group 1 metals are on the left-hand side of the periodic table, and therefore they are metals. Because they are metals, they have good conduction of electricity and heat, and they are shiny when they are freshly cut. So we can say that, like other metals, Group 1 elements are good conductors of electricity and heat, good conductors of electricity and heat, and they are shiny when they are freshly cut. So shiny when freshly cut. So they are metals, they're good conductors, and they are shiny when freshly cut. But in some ways, the Group 1 metals are different to other metals. So we can say, in some ways, comma, Group 1 metals are different to other metals. Full stop. Now, a good way to show this is with the table off the PowerPoint, which looks like this. These are the group 1 metals: lithium, sodium, potassium, rubidium, and it's being compared next to some non-group 1 metals. So these metals are found in group 1, these ones are not, as indicated by this table. If you notice that the group 1 metals have really low melting points, copper and platinum are not group 1 metals, and they have very high melting points of 1083 degrees Celsius and 1796 degrees Celsius, whereas rubidium only has a melting point of 39 degrees Celsius. Okay? So we can say, and I'm going to put it in red because it's important, that group 1 metals, it's the worst G ever, group 1 metals have a much lower melting point than other metals. If you are doing this in your exercise book and you don't have a printer, it would be worth drawing out this table, okay, and writing it in your book. So, I need to refresh the screen. You can pause this video and go back wherever you want. So, let's have a think about the physical properties of the group 1 metals. So, physical properties of group 1 metals. And in order to do this, we're going to need this table again. I'll make it a bit smaller. And we're also going to need the second table that I've put on the PowerPoint that looks like this. Now, these two tables show the melting points and the boiling points of the group 1 metals. Now, as far as this one's concerned, we're not interested on this part with these bottom two elements. Okay, we're not interested in copper, and we're not interested in potassium, in platinum. However, we are interested in lithium, sodium, potassium, rubidium. Okay. Now, if you look at these data, you can see that as you move down group 1, as we go from lithium to sodium, potassium, rubidium, so lithium, sodium, potassium, rubidium, the melting point drops. So I'm going to put in red because it's important as we move down group 1 elements comma, their melting point drops. Their melting point drops or decreases. If we have a look at this one, the boiling point, lithium's boiling point, which is at the top of group 1. If we look at the periodic table, lithium's at the top. Its boiling point is 1330, and as we move down to rubidium, it drops to 688. Okay? So as we move down group 1 elements, their boiling point decreases. So as we move down group 1 elements, their boiling point decreases. Okay? So as we move down these elements, so as we move down group 1 of the periodic table, as we go from lithium down to francium, the boiling point decreases and the melting point decreases. So boiling / melting point decreases. Okay, so as we go from lithium down to francium, the melting point decreases and so does the boiling point. Final thing we need to think about today are the chemical properties. So I'm going to refresh the screen and we can put the subheading what are the chemical properties of group 1 metals. Now, just for reference, I'm going to add in this periodic table so that we can use it as and when, okay? Now, the group 1 elements are very reactive. They are incredibly reactive. So, group 1 metals are very reactive. Okay? Now, interestingly, as far as patterns go, as we move down group 1, their reactivity increases. So lithium is the least reactive, whereas francium is the most reactive. So we can say, as we move down group 1, comma, elements, or in fact no, as we move down group 1, reactivity increases. So lithium is the least reactive and francium is the most reactive. Okay? So I'm going to put here, lithium is the least reactive and francium is the most reactive. Now, if the group 1 metals are left in air, they go very dull. This is because they are so reactive, they react with the air around them. So we can say that group 1 metals kept in air will go dull as they react with oxygen. Okay? For this reason, we store group 1 metals in oil to stop them reacting with the air. So we store group 1 metals in oil to stop them reacting with the air. Okay, so we store the group 1 metals in oil so that they don't react with the air. Now, group 1 elements have violent reactions with water. If you think of your central heating in your house, hot water is going through the copper pipes. That copper does not really react with the water because it is so unreactive, whereas if your copper pipes were made of lithium, sodium and definitely potassium, your house would catch fire because these metals react so violently with water. So we can say that group 1 metals react violently with water. Okay? When they do this, they form hydrogen gas and a hydroxide compound. So if we were thinking of this as a word equation, we could have, for example, lithium plus water. So these are our reactants. When we react lithium and water together, we get a reaction. Remember, we draw an arrow, we don't draw an equal sign, which would make, in this case, lithium hydroxide and hydrogen gas. Okay, so we would get lithium hydroxide and hydrogen. These are our reactants. Okay, so we can say underneath here that group 1 metals react with water to form a metal hydroxide and metal hydroxides are alkaline. So they are alkaline and hydrogen gas. Now, I mentioned earlier that when you react these metals with water, you get different reactions. So lithium, for example, will just fizz around the beaker of water. You'll see fizzing, but not much else. Okay? So we can say that lithium fizzes around the water. Lithium fizzes around the water. But as you move down the group 1 elements, they get more and more reactive. And if we look at the reaction of potassium, potassium actually bursts into flames. Okay, you'd get a lilac flame from potassium when you drop it into water. So potassium catches fire. In water. So as we move down the group 1 metals, they become more reactive. They are violently reactive in water. Lithium, for example, only fizzes around in the water, whereas potassium catches fire in water. Therefore, we can say reactivity increases as you move down. If I react lithium with water, I would have lithium plus water makes lithium hydroxide and hydrogen. If I therefore react potassium with water, I would get potassium plus water makes potassium hydroxide plus hydrogen. These metals are so reactive that we have to store them in oil so that they don't react with the air. So by now you should be able to tell me where the group 1 metals are found on the periodic table. You should be able to describe some of the physical and chemical properties of the group 1 metals, and you should be able to compare some of the properties I've spoken about today with metals that we've already learnt about. Should you have any questions, let me know via email or via Google Classroom, and until the next video, take care.